Yo, okay, ready? Yo, I'm in algebra with my dogs. Today we're going to talk about some logs. Hey, I'm loving this rhythm. Time to learn about properties of logarithms.
Oh,
word.
Good job. Okay, so you're next time, Dayton.
I'm next time?
Yeah. All right, properties of logs. Before I show you the 3 properties of logs, I want to show you one little side note here. So this is not one of the 3, but this is called change of base. Y'all keep asking me about your calculator, so I'm finally going to show you how to put it on your calculator. How to put a log on your calculator. It'd be what? Alright, so here's what you have to do. If you have change of base formula, it tells us we can take any log in any base and we can rewrite it using a base of our choice. Okay, so maybe I want to use a base of 10 because that's a common base, right? We've talked about common log, right? That's okay. We talked about common log, right? Okay, sidebar. There are 2 types of logs. There are what we call a common log. Okay, so anytime you see a log written without a base on it, say the log of 5, there is an imaginary 10 here as the base. That is called the common log. That is the log that your calculator does when you click the log button. Okay, so log base 10 is a common log. The other kind of log, and we will do a lot more with these 2, but just so that you know what they are so you can use your calculator, okay? The other one is what we call the natural log. And we have talked about the number e plenty of times. We did that when we did growth and decay, right? Okay. Natural log is actually a log that has a base of e. Okay, and when you have a base of e, we write it as ln. That's an L. It's not an I or a 1. It's an L. We write it as natural log of x. And so there's also a natural log button on your calculator. It should be right close to the, right close to the log button, okay? ln. All right, so those are your two very basic kind of logs, most common kind of logs we use. All right, so remember, if there's not a base written, because math is known for all the, imaginary things, if there's not a coefficient, it's a 1. If there's not an exponent, it's a 1. If there's not a root, it's a 2. If there's not a base, it's a 10. Okay? What? You use ln x. But what ln x means is that it's a log base e. So if you see any log base e, it's the same thing as the natural log button on your calculator. It's right beside the log. What are you confused about? No, this is a sidebar right here, just to tell you before. If I were to type, and let's think about this for just a minute. Let me show you. If I wanted to know the log of 100, okay, and there's no base there, that means there's an implied base of 10, right? So I know from my experience with logarithms that what should this equal? 2, right? Because 10 to the what power gives you 100, 2. So on your calculator, hit log 100. Okay? You don't have to. This only works when it's a base of 10. So if I asked you what is log base 2 of 5, it doesn't work anymore because the base is different, right? That's why I was telling you your calculator won't work just yet, and I hadn't showed you anything on the calculator, because it's only a base of 10 or a base of E. Okay? You could, if you wanted to. You could do ln. But did you see the natural log button here, Marshall? Okay.
Where's the natural log?
Oh, it's okay.
It's second?
Natural log button is under the log. E is, you have to hit second natural log to get to the E. Same thing, you put whatever you want in for the exponent, e to the first. There's above the divide, there's also an e, that's just e without the exponent. It doesn't matter, it doesn't matter, there isn't one. Alright, so if I wanted to do natural log of something, I would hit natural log of whatever I wanted to do, and it would give me the natural log of that value. That's saying e to the 4.6 power would give you 100. That's the one we learned a few sections ago. That you're at 2.71, right.
So then how do you get the base? Is ln just for the e?
Yes, e is only for the natural log. You don't have to put it in there, it's already in there. If you ever see any log base e, if I said, what is log base e of 10? Well, then what I'm really asking you is, what is the natural log of 10? And nobody's going to write it like this. They're going to write it like this. It's up to you to know that this means that. Does that make sense? Okay. Now, I digress to show you that your calculator calculates logs in two different bases. It calculates them in base of 10 and it calculates them in base of e, right? Are y'all with me on that? So now let me go back to this change of base formula that I was showing you. If I have a log base b of a, so whatever base it is, I can change that to any base I want. So if I'm wanting to use my calculator, the smart thing to do is change it to a base of what? 10 or e. Because those are the two bases in which my calculator operates. Does that make sense? Okay, so I can change this by saying the log base 10 of a divided by the log base 10 of b. Okay, same thing. Or I could do, you can make it any base you want. It's got to be the same top and bottom. So maybe I want to do natural log. The whole point in this is so that I can use my calculator to find these values. And how handy is that when we're struggling with values, especially decimals and things, right? Let me show you exactly what I mean. We still haven't gotten to the properties of logs just yet. So yeah. Let's say you to think critically and analytically and solve problems. So for example, let's say I asked you, what is the log base 3 of 12? Can you do that without a calculator? What is it? No, because 3 to the second power is 9. 3 to the third power is 27, so it's somewhere between 2 and 3, but there's no way for me to do that, right? So I have to use the calculator, and I'm going to have to use a change of base when I do it. So what I'm going to do is do the log of 12 divided by the log of 3. Always. So it's always the log, and I used to say log of big divided by log of little all the time, but I'm not talking about numeric value, I'm talking about the way it's written. And as long as you understand that, that's fine. 2 decimal places is good. Just to show you that this works. 2.26. Let's take a log that we know without using the calculator. And then check it with the calculator. In other words, let's say log base, we'll use Mary's favorite. Log base 3 of 81. We know that that actually equals what? 4. Let's check it with the calculator. If change of base operates correctly, then I should be able to do log of 81 divided by log of 3. By the way, what is the base that I'm changing to? 10. Log of 81 divided by log of 3. Imagine that. Try this. Do natural log of 81 divided by natural log of 3. Yeah. It's a rounding issue. Instead of 10, it's a rounding issue. You can use either one you want. It doesn't matter.
Wait, so why is E equals 2 and 7 and natural and common logs of 10, but it equals 0?
Because you can do any, this formula lets you put any base that you want right here. So we did a base of 10. You could do a base of E, which is the same thing as natural log. If you wanted to, you could do a base of 25. It doesn't matter what base you use, as long as it's the same top and bottom.
So why are there 2 different ones? Like why is there this is 10 and why is this 6? Not in this, but like just on top of it. Like why do they have
This the most common logs that are used.
Oh, you said there's more.
Well, the most common bases in log. The most common one used is actually not the common log, it's the natural log. That's the most real life applicable log that there is. You'll see that, when you get to higher level math, you'll use all natural log all the time. I don't recall using a lot of other logs. All right, let's do our properties. We haven't really begun. And now we start. There are 3. These very closely line up with the properties of exponents that we talked about. Remember those 7 properties of exponents we talked about? And y'all looked up and said, that's so easy, that's so easy. And then we put them all together and you're like, I don't know how to do this, I don't know how to do this. It's going to be the same kind of thing with logs. This is the way it always goes with logs. So stay with me. The properties themselves look pretty easy, but when you put them together, it gets kind of convoluted a little bit. So I think the easiest thing to do is to give you the 3 properties, show you an example of each property, and then we'll put them together and work through them and see what happens. So the first one, again, I don't care that you know the names of them. I just like for them to be labeled. You will notice that they even sound a lot like the properties of exponents. Product property. Remember, logs are exponents, and so that's why these are going to closely mirror each other. 3. Oops. Let's do x, y. I know, I'm sorry. You can use any variables you want. But you can't use b again because you already used it for the base. Now, back to exponents. Whenever you multiply 2 terms that have the same base, what do you do with the exponents? You add. Keep that in mind. It's going to help you here. Because on this one, I can split this up with addition. You have to write the log twice, okay? Every time you multiply, you write in the log. So every time you split up, you have to rewrite the logs. It doesn't just become log base b of x plus y. It's log base b of x plus log base b of y. And it's a lot, right? So when we do that, this is called moving from left to right. This is called expanding the expression. Okay? We make it longer than what it started as. Now, in the same manner, if we move from left to right, so if we make it shorter than what it was and we use only 1 log to write it, and the key here again is these bases have to be the same, just like with exponents. This is called condensing. So if you make it bigger, it's expanding. If you shrink it in, it's condensing. Does that make sense? Okay. I'll show you an example of each with this property, and then we'll do property number 2. Who are you taking a picture of? A bunch, because this pen piece of crap.
Yeah, it's like in the video. It's yeah.
I'm sorry. Okay, that's me writing on the board though. Expand that. Hard. All right, so to expand it, I'm log base 2 of 5 plus log base 2 of x. Is that what y'all got? Let's condense one and we'll go on to property number 2.
So what do you do from there?
Wait,
That's
I
it.
didn't see what you put.
Yeah, think about 18.
Okay, yeah.
Okay.
Wait. Do it.
Yes, but I'm gonna also show you something with the exponents like that, so hold that thought.
Boil the law.
Condense. Yeah, there's
What if there's not? Well, if it's a long.
if you can simplify it whole number, I'll tell you what I want you to do. Right here, I just want you to condense. Do you notice that all the bases are the same? Oh, man. Sorry. Golly. Do you notice now that all the bases are the same? Yes. So I can multiply, okay? And because multiplying is easier than subtraction and division, so here I can just put everything together at one time. 3 times 2 times y. And it's condensed. You know it's condensed when there's only one of the log with that particular base in the problem.
What if that log
Can't what?
did have a base?
You could do 6 plus y. Huh? You could if I asked you, but I'm not gonna.
So from condensing that, we can then expand.
Well, then you'd be back to where you started.
Well,
Yo, wait, don't overthink this yet. Just wait until we get to them combined. Take them one property at a time right now. One thing at a time. All right, let's do number 2. Yes, second property. Quotient property. Quotient means
divide.
when you are dividing with the same base, what do you do with the exponents?
Subtract them.
Subtract them. So I have log base b of x minus log base b of y. Again, left to right is expanding, and right to left, condensing. Me too. All right. For example, expand. I always remember this because the division sign looks like a subtraction sign. Questions about that? These are easy examples to go through. We will get harder, yeah.
Let's say if it said to simplify, would you write it out as log 2x and like solve for log 2, 3?
Yes, if it said to expand, then simplify, yes.
Wait.
But you
Log
won't,
2, 3 should be simplified.
yeah. You can put it in your calculator and find it. How about this one? Condense. Now you might want to make a note under your quotient property that whenever you start throwing subtraction in there, what you want to do is you want to move left to right no more than 2 at a time. And there's a reason for that. You don't want to just divide, you don't want to say x divided by 2 divided by y because it's going to throw you off. So do the first two first, and that should be pretty easy, right? Uh-huh. And now, what happens, and I'm going to come off to the side, what happens when you divide a fraction by something? That's exactly right. So, this becomes x over 2 times 1 over y. So this would condense to log base 3 x over 2y. Does that make sense?
Yeah.
Last property is the easiest property, so take a deep breath. We're almost there. That's a 2. Property number 3. Power property. This is everybody's favorite because it's so easy. Mm-hmm. What happens with exponents when you have a power raised up to another power? What do you do with them? They're multiplied. You multiply them. Do the same thing here. You're going to take the highest power here, bring it around front, and multiply it to everything. And for the last time, from left to right is expanding, and right to left, condensing. For example, log base 3 of the square root of x. But Miss McGee. There you go. Who said it?
X and negative 1, I thought we did 1/2.
Somebody said 1/2. It's 1/2. Somebody said 1/2. 1/2. This square root of x, you said it, Dane, is x to the 1/2. So your exponent here after this, I'll put this up here to throw you a little bit. Trying to wake you up. Clearly. Y'all are like, I feel bad because I kind of feel like that too. Like even my eyes feel swollen. Like, I don't know. You always feel like that? All right, so bring it around front. And it's expanded. You'll encounter this a lot with the radicals. Just keep in mind that square root is a radical of 1/2. Is an exponent of 1/2. Cubed root, 1/3. And so they act as exponents.
So is A1 in this? I'm thinking this is
Huh?
Is A1 in this?
A would be x. What do you mean A?
A would be X.
I'm not sure what you mean.
Oh, I'm just saying. Yeah.
Yes.
So if we were to set like 1/2 of log 3, then what would it be?
If you said, hold on. Now it's not gonna work at all. 1/2
Of log 3,
that would just be 1/2. All right, let's put some things together. Ready? Putting it all together is the hard
What about
part.
condensing?
Oh, you want to do a condensing? Okay. If I condense this, it comes around on the, anything multiplied in front. Yeah, or the square root.
Then what's the other 1/2 then?
I was just saying if you simplified that expression, because log base 3 of 3 is 1.
And so it's like an answer?
Yeah. All right, let's put them together. Here's where we separate the boys from the men. Okay. Log base 6. Let me give you some hints before you start this. It's a good idea if you have a fraction to always split the fraction up first. Always look at what your exponents are being applied to. Okay? This is an easy one to start. We'll delve a little deeper in just a minute. But look for what you can split up. You got to make sure that if you condense it back down, it comes back to the same thing. Okay, so you got to follow properties each time. So remember, always look for fractions to split up, and make sure you look. This 3 is only going to the x. It's not going to the 5, right? It would be different if it was written this way. Those are two different expressions. So be careful of that. So first thing we should do is split it. Split it, right? Split it, split that fraction up. So as we expand, I have log base 6 of 5x cubed minus log base 6 of y. Is that it?
No.
So what you're looking for as you go make your way through the problem of expanding, you're looking for anything being multiplied, divided, or exponentiated, because those are the 3 properties that you have. Now, if it was written, if that first term looked like this, I would need to take care of the exponent first. But because the exponent's only on the x, I can go ahead and split that 5 and x up. Do you see that? So how are you going to split it up with what? So log base 6 of 5.
Would you put the first 2 in parentheses?
You can, and it's not a bad habit to be in, because if your denominator had multiple parts, you'd really want it in parentheses. So if you want to go ahead and get in the habit of putting those in parentheses, it's not a bad thing to do. Well, if this had been in the bottom, I would have to watch this minus sign because it would be distributing through. So it's just not a bad idea to keep it grouped together with parentheses, but you don't necessarily have to. All right, do you see anything else I can do?
The exponent.
The exponent, it can be brought around. So my final answer expanded would be log base 6 of 5 plus 3 log base 6 of x minus log base 6 of y. Now this could be log, this could be ln for natural log. Okay, same properties there.
So when we do the,
So would you want us to do log base 6 of 5?
No. Leave it like that. All right. I hear that's not too bad. Let's do a condensing one. Now on these, what you want to do is you want to do the exponents first, and then you want to do left to right, no more than 2 at a time. Are there?
There is three left, yeah.
Mm-hmm. That can come around to the front.
So there'll be 2 to the third one.
Exactly. So I have log, and remember the goal at the end, whenever you condense, is having log written only one time. Plus log, what is 2 to the third?
8.
Now what?
900.
Which is, uh-huh. Now what?
72 divided
Condensing always seems to be easier for whatever reason for students. This one is nice because there were no variables and it was just all numbers.
72 divided by 3.
72 divided by 3, yeah. Now, this is probably what students struggle the most with expanding and condensing. So let me show you because this is on your homework. No, not on this. Let's say I told you, you may not use a calculator for this, that the log base 4 of 3 is approximately 0.792. And the log base 4 of 7 is approximately 1.404. And I said, showing all your work and not using a calculator, how might you find the log base 4 of 3 over 7? Split it up. How might I split that up?
Log 4.79. No?
What is log base 4 of 3?
0.79.
What is log base 4 of 7? So approximately I would get negative. So that one was easy. What if I asked you log base 4 of 21? Multiply what? 3 times 7. I'm going to try to relate 3 and 7 back to this number by multiplying, dividing, or exponentiating, because that way I can expand it and I can use these values.
So is that the same thing?
So this time, instead of subtracting, I'm going to add, because 3 times 7 is 21, and plug in the values.
Oh, it's just like which one? It's like congruent things.
It's like what's the same? Yeah. How about that one?
7 times 7.
Oh, I don't know. Whatever you get whenever you add them together.
2.1.
There you go.
What is it,
49 I could do 2 ways. 7 times 7? Give me another way to do it. I could do 7 squared. I could bring that around front and say it's the same thing as 2 times log base 4 of 7. I don't know why students struggle with this so much. I don't know if it's because you're actually using values in there or what, but it is a lot. There's a lot with properties of what is what? The base.